Today we are going to do 3-2 solving systems algebraically. So you will be able to solve a linear system algebraically. The big idea is you can solve a system of equations by writing equivalent systems until the value of one variable is clear. Then you could substitute to find the value or values of the other variable or variables. So you can use the substitution method to solve a system of equations when it is easy to isolate one of the variables. After isolating the variable, we substitute for that variable in the other equation, then solve for the other variable. So we have a system of equations, 3x plus 4y is equal to 12, and 2x plus y is equal to 10. I'm going to go ahead and number these equations 1 and 2 so it's easy to refer to them. In equation 2, I see that y is by itself, therefore it would be most convenient to isolate for y. So I'm going to take equation 2 and solve for y. So I'm subtracting 2x. Y is equal to 10 minus 2x. Now that I have what y is equal to, I'm going to substitute the expression for y in the other equation, or equation 1, and solve for x. So 3x plus 4 times 10 minus 2x is equal to 12. I'm going to distribute that 4. I get 3x plus 40x minus 8x is equal to 12. Combine like terms to get negative 5x plus 40. This is not 40x, it's just 40. Is equal to 12. I'm going to subtract 40. And I get negative 5x is equal to negative 28. I'm going to divide by a negative 5. And x is equal to negative positive 5.6, because a negative divided by a negative is a positive. Now I'm going to take this x value and substitute it into one of our original equations to solve for y. So 2 times 5.6 plus y is equal to 10. 11.2 plus y is equal to 10. I'm going to subtract 11.2 from both sides. And y is equal to negative 1.2. Therefore, I have the solution to my system, which is 5.6 comma negative 11.2 as my solution. So, problem 2, we are going to use substitution to solve a problem. A music store offers piano lessons at a discount for customers buying new pianos. The cost for lessons and a one-time fee for materials, including music books, CDs, software, etc., are shown in the advertisement. What is the cost of each lesson and the one-time fee for materials? So, we have 6 lessons is equal to $300. 12 lessons is equal to $480. We know that the cost of 6 lessons, so 6 lessons plus the one-time fee is equal to $300. We also know the cost of 12 lessons plus the one-time fee is equal to $480. We're going to define our variables. So we'll let C equal equal the cost of a lesson, and we'll let F equal the one-time fee. So we're going to write two equations. We're going to have 6C plus F is equal to 300. And we'll have 12C plus F is equal to 480. We're going to use substitution to solve this, so I'm going to pick my first equation to solve for F. So I'll have F is equal to 300 minus 6C, because I moved that C over to solve F. Now I'm going to plug this expression of F into my other equation. So I have 12C plus 300 minus 6C is equal to 480. Combine like terms. 6C plus 300 is equal to 480. Subtract 300. C is equal to 180 divided by 6. C is equal to 30, which means the cost of one lesson is equal to $30. We can plug that back into our original equation. 6 times 30 plus F is equal to 300. 180 plus F is equal to 300. Subtract 180. F is equal to $120. Meaning our one-time fee was $120 and the cost of each lesson is $30. We can also use the addition property of equality to solve systems of equations. If you add a pair of additive inverses or subtract identical terms, you can eliminate a variable. So what we want to do is find variables with the same coefficient to either add or subtract so that we can eliminate the variable and solve for one of our variables. In this system, 4x plus 2y is equal to 9 and negative 4x plus 3y is equal to 16. Our x terms have the same coefficient. So we have 4 and negative 4. Those are going to be additive inverses because 4 plus negative 4 is going to be 0. So if we add our two equations, we're going to add both of our equations. 4x plus negative 4x is 0x. 2y plus 3y is 5y is equal to 9 plus 16 is 25. Divide by 5 on both sides to get y is equal to 5. Once we know y is equal to 5, take y and plug it into one of our original equations. So 4x plus 2 times 5 is equal to 9. 4x plus 10 is equal to 9. Subtract 10. So we have here that x is equal to negative 1/4 and y is equal to 5, making our solution negative 1/4, 5. When we multiply each side of one or both equations in the system by the same non-zero number, so by a constant, the new system and the original system have the same solution, so it is not going to change our solutions that we come up with. The two systems are called equivalent systems. You can use this method to make additive inverses, so we can use multiplying by a constant to one or both of our equations in our system to then eliminate a variable. So here we have a system of two equations, 2x plus 7y is equal to 4, and 3x plus 5y is equal to negative 5. If we multiply the first equation by 3, then we would have this entire first equation by 3. So 3 times 2x is 6x plus 21y is equal to 12. And we multiply the second equation by negative 2. I'm going to get negative 6x minus 10y, is equal to 10. If I then add these two equations, I have 6x plus negative 6x, which cancel to 0. 21y minus 10y is equal to 11y. 12 plus 10 is 22. Solve for y, and y is equal to 2. We then can use y and plug in to either of our original equations to find x. So 2x plus 7 times 2 is equal to 4. 2x plus 14 is equal to 4. Subtract 14. 2x is equal to negative 10. Divide by 2. X is equal to negative 5, making our solution negative 5, 2. And our last problem, solving a system algebraically does not always provide a unique solution. So we can get infinitely many solutions, and we can get no solutions. So we're going to solve these two systems of equations. This first system, since I have common coefficients of my variables, I am going to add the two equations. So negative 3x plus y is equal to negative 5, plus 3x minus y is equal to 5. Negative 3x plus 3x is 0. Y plus negative y is 0. Negative 5 plus 5 is 0. So 0 is equal to 0. Since this is a true statement, we have infinitely many solutions. In B, I'm going to add my two equations again. 4x plus negative 4x is 0. Plus negative 6x plus negative 6y plus 6y is 0 again. 6 plus 10 is 16. Since 0 does not equal 16, this system has no solutions. That's it.